All right, let's see. We got sound there. We got green light there. We should be good to go. Welcome and good morning. What's this? Oh, there it is. Okay. There we go. All right, there we are. Welcome. Good morning. Thanks to anyone watching. My name is Tim. I go by Foamy Guy on GitHub and Discord. I stream at this time every week, typically on Saturday mornings around 10 a.m. Central Time. We're a few minutes early today, but I am usually always working on something related to CircuitPython. If you're new to the stream, if you haven't caught them before and you don't know, CircuitPython is a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them over here on the downloads page. The typical way these will work with CircuitPython is you plug them into your computer with a USB cable. They show up like a thumb drive. You can edit a Python code file on that thumb drive, and then the tiny computer that's actually on these boards in the chips will read and interpret and execute that Python code file for you. And then, within your code, you can set it up to interact with whatever other electronic bits are connected to it. So lots of these microcontrollers will have all these pins along the sides or somewhere where you can connect up other devices. Some of them have things built in, like this one is almost like a little tablet type thing. It's got a touch screen built in and a couple of other built-in features. This one's got some Cherry MX compatible keys as well as a screen and a knob. So these little microcontrollers come in all different shapes and sizes. All the ones on this page are capable of running CircuitPython, which is what I usually work on, something related to CircuitPython on stream. If you would like to learn more, CircuitPython.org is a good place to do that, or join us over on the Discord. There is a CircuitPython dev channel where we coordinate all of the development of CircuitPython. There's weekly meetings that occur where you can sit in if you'd like to kind of keep up on whatever is the latest stuff being worked on. There's also a help with CircuitPython channel, so if you are trying to use CircuitPython for your project or you're trying to get it working on a new device or something like that, you can come on into the Discord and ask for help, say hi, introduce, show what you're working on. If you want to have other folks take a look at it, all that kind of stuff is encouraged, so head over to the Discord for that. I think that is still linked down below, right? We still keep that one on there? Make sure. Yeah. Okay. As always, thank you to Adafruit. Adafruit is a company that makes kind of the development of CircuitPython possible by paying the folks who work on it. There's a team of folks who work on CircuitPython full-time and are paid by Adafruit to do so, and there are some folks like me who are paid part-time to work on the project. So, as always, huge thanks to Adafruit for paying the folks who work on it, making this whole project possible. And then if you want to help support Adafruit and CircuitPython, one of the easiest ways you can do that is just head over to their website, adafruit.com, and purchase hardware there. That hardware will ship out of New York, where Adafruit runs the factory. They design and manufacture electronics there, as well as store and ship. So huge thanks to them. Happy Pride Month to everyone. We do have the nice Pride flag for June at the top there of adafruit.com. But head over there if you would like to get yourself some neat toys. And thanks, as always, to everyone who does purchase hardware from them for kind of keeping this whole thing going. So I am jumping right back in where we left off last night on the deep dive. So if you're interested in kind of the preamble, so to speak, or the precursor to what you're about to watch, you can find yesterday's VOD for the deep dive. Basically, we are trying to interact with BLE workflow, which is a way to manage files on CircuitPython devices over BLE instead of USB, which would be kind of the typical way. So we're in the kind of early stages of getting this interaction working, this integration working with the BLE workflow. Specifically, my aim is to do it from PCs, from a Linux PC in my case, but ideally, hopefully, we'll be supporting Windows and Mac as well. The library that I use for BLE, I think, is cross-system compatible, so hopefully it will be a thing that can work in all of them. But this is going to enable us to use utilities like Circup over BLE instead of USB or Wi-Fi. That's the plan, at least. So specifically, we're working on the read file command And where I got to yesterday is we're sending the read file command, we're receiving the responses back. Those responses contain the file, and when the file is smaller than the chunk size that we're asking for, then everything works correctly. We get our response back with the header, we get our response back with the file, and the file content is all there, and we're good to go. However, if we ask for a file that is bigger than our chunk size, the microcontroller is going to send us the header, then it's going to send us the first chunk, and then the next chunk, and the next chunk, until it has reached the entire, end of the file that it has sent to us. And for each chunk, it's going to send us one chunk, and then it's going to wait for us to ask for the next chunk, effectively, to send this read pacing command, and give it the offset of where we left off. So, what we received last time, we need to not receive it again. So we need to set the offset to kind of the next, index or whatever. And this logic is not working. And kind of in the back of my mind after the stream last night, I was thinking about it a bit more. And I believe kind of the main reason why it's not working is we have this while loop in here, which is making this chunk of code that's inside of it repeat, obviously, because that's what a loop does, until some condition is met. But the truth is we are inside of attempt parse file, which gets called by callback handler, which gets called because we set start notify, and we gave it the callback handler. So anytime we receive incoming data over BLE, callback handler is going to get called. Inside of there, we're adding the new data to an incoming data buffer, which is going to ultimately store the entirety of the data that came into us. And we are calling attempt parse file. And then we're checking, was our attempt successful? If it was, we want to print out the contents of the file. And we're trying to write it to an actual file on the disk of the PC at this point. The thing is, though, we don't really want this to loop, right? This has a while loop because the code where I stole it from inside BLE file transfer library, it has its loop, and it's actually reading data from the BLE inside of this while loop. So it's like read a chunk, do some processing, and then check the condition. And if we need to, then read another chunk, do some more processing, check the condition, read another chunk, so on and so forth. Conceptually the same kind of thing is happening, but we don't really want it all to happen inside this while loop. We don't really want it all to happen inside of this one call to attempt parse file. Instead, we know that as soon as we receive another incoming data, this is going to get called again. So we should not be looping inside of here. We should just be waiting for this to get called again, and then we want to check, do we have the full message or not? And we should also, I think, not be using buff at all, right? This is creating buff as a list. I don't know why it's a list. Eventually it's a byte array, I thought. Yeah, well, maybe it's a list of bytes or something. I don't know. Ultimately, it represents a byte array, I'm pretty sure. And we were trying to return buff at the end of this when everything is done right here. But the truth is, I don't think we want to do that. I think we should just be returning the data buffer when it's ready. Or I guess actually what we'll want to do is, so at the end, once we've received everything, the data buffer is going to contain two things: a header, which is like a little blob of data, and then of like bytes and stuff that represents the size and a few other things, and then the actual raw content of the file. So really what we want to return is, I think, just the raw content of the file. So we could take that entire data buffer, which we know by the time we receive everything, that's going to include the header and the content. We can strip out the header and then return everything after that, and that should be just the content. And we can do all of that without, we don't need this buff. We shouldn't be creating another one. I think we should just be building up data buffer, which we already are because of the way the rest of this works. We don't ever really need to take stuff out of data buffer and put it into buffer. I don't think we need to do any of this. So I think what I'm going to do is for now comment this entire while loop, and we already have this, which is our final kind of are we done check. We don't have content length anymore, but that's just because I stopped unpacking. So we do need to, we need to unpack so that we can get the length. I think we probably don't need to worry about chunk done either. The offset, we will need the offset maybe. But our offset's going to be, we're going to calculate the offset different. Let's just do this. Let's start with this, just this. So I'm trying to avoid grabbing more code than we really need. Right, because it's a comment now. I was like, why did the while disappear? Okay, so this first chunk here, this part of the header, that's going to tell us the total content length, which is then going to allow us to know if we are done or not, because total content length plus header size, we know we're done when we've received that much. And then if we're not done, what we need to do is just write the read pacing command, right? We don't need a while loop. We don't need to like have a condition and be looping inside of here writing that thing. Instead, we just write it once, and we know that when we receive the data back, we'll get another callback. That's our looping mechanism is, you know, we're effectively in a recursive method here. It's not directly recursive because it's not calling itself, but it's going to be writing the command over BLE, which is in effect causing itself to get called, because we know when we receive data it will get called. Okay. I think that was always yellow. I'm not sure why. Maybe because it's sometimes none, but eventually it gets set to the client, so I think it's just a little confused about that. Chunk size, we don't like this. Why? Unresolved. Okay, so current offset. So when we pass in the read pacing command, the offset we want to ask for is it is the number of bytes that we've received so far. And that can be calculated with length of data buffer minus the header size. because that's going to be how much of the file we have received so far. And then our offset, that's where we want to start. We'll have to check. Maybe we're off by 1. Or maybe there's like some hex or some. Maybe we need to convert it somehow, but I'm pretty sure that's what's going on there. And then chunk size, I believe we were just hard-coded before to always doing 1024. Where did chunk size get set? Chunk size equals minimum of chunk size and basically how much is left. But I'm pretty sure the doc said we could just make it bigger, right? Couldn't we just always say chunk size is the same? Maybe different than the original size. So that means different than the size of the first one. Does not need to be limited by the total size. Total size of the file, it means. So yeah, I think we should just always, let's just always ask for the same amount, which is currently hard-coded at 1024, I think. All right, so we write the read pacing command in order to trigger more data to get sent. We return false from here because we don't have the full file yet. And then that's basically it, right? That's going to happen. Whenever we do have the full file, we're going to return it. Whenever we don't have the full file, we're going to basically send that read pacing command again, turn false and none. Which is way simpler, and I think what we need to happen. So I do need to get this thing into BLE mode here. I have a feather sense. No powered Bluetooth? I turned it off because... Oh, I was trying to disconnect my headphones. I guess it did, but... So that, I think we need to go remove device. I don't know why. If there's a way to do that from the code. I do still have a bit of the weirdness with, uh-oh, no, it looks, oh. I was gonna say it looks like we're in an infinite loop, and it did. And we didn't work because we didn't stop. I'm not entirely sure actually why it stopped. So let's print out here. Print asking for more data. Offset is offset, which we calculated. Let me put a variable for offset. We already have current offset, I guess, but. So I guess one thing we saw yesterday that it can go infinite. This I guess should be like greater equals, but and then if it's equals, it was successful. If it's greater than, something went wrong. So this we also saw yesterday, this failure mode, if it's the same thing, the way I was fixing this yesterday was basically restarting the VM by using Control-C or Control-D. Although we did get this, which is actually a different failure mode. The way I was fixing that was just going back and forth there, which I think like wakes up or just jogs the Bluetooth adapter. I'm not really sure. Okay, we are still in this failure mode though, for real, where the way I was fixing it was TO and just, if you were in CodePy, break to REPL. If you were in REPL, then run CodePy. Either way of which I think restarts the VM. Yeah, I don't know why. I guess I'm not sure why this stops, honestly. I would have thought this would have just kept going. It's kind of weird. I guess it just gives up after a while? It never returned true. Therefore, it should have always been writing, asking for more, and then receiving more. Guessing I messed up the offset somehow. So for one thing, we didn't print it out correctly, so that's very useful. Okay, so that seems to perhaps reliably get it into that state where it doesn't work. Okay. So the first thing we received was only a header. It had no file content. So then when we asked for more data, we said our offset is 0, which would have been the same offset we sent the first time. Then we started receiving data, and we received the actual data from the file. And so about to return is saying the current length of the buffer and then the expected total size. Okay, BRB. I didn't go to the restroom before I started, my bad, but BRB. Okay. So 512 is our total size. We set our offset to 496, so that is 16 off. Is that the size of our header? Let's print the header size. Let's print the header size, he says, as he just hard codes 16. Yeah, that's a good way to check if you're correct. Just print out what you thought it was. And I assume this will be crashed again. We need to reset, probably. Yeah, header size is 16. So just to make sure, so we received 512 total bytes after the second receive. The first one we received 16. The next one we received, we have a total of 512, but we have the header, so we asked for an offset at 496. Makes sense to me. So let's see if we matched up here. So we have this. I'm going to make a temp directory because I have a feeling we're going to have a bunch of these, and I might want to keep some of them. So this is after, I'm going to say it's after second receive because we received the header by itself first. I'm going to do the trick. Okay, so we have a fro. Presumably it's part of from. And then we did start with an M. So that part seems okay. Got our M right there. Trying to, I'm going one at a time here so that we can skip the one. Yesterday we found there's one that's not supposed to be a real new line. It's a new line in the code. We're like going Inception here. We got new lines inside of new lines inside of escaped and unescaped inside of, yeah, dream inside of a dream. So then the next one, then so we had 512 total here. We asked for an offset of 496. So what's weird is we asked for a chunk size of 1024, but we actually did not get 1024 back. We got 490. We got 1008 minus 496, which is 512. Okay. Which is how much we had after the second return as well. So then 496, so 512 plus 496, is that 992? Okay, let's keep going with this. But I think we're off there, probably. Well, maybe not. We have the header still. Okay, here's the next thing we received. It looks like we have imports again. I think we looped or something? And monotonic. Okay, we got to monotonic. We have another copy of the header. Okay, we have a whole nother copy of the file. We completely restart. Actually, we might have looped even earlier. Actually, we have this. Oh, okay, no, those are two different ones. We had while not, and then we have while is. But what's the actual code? So we had while BLE connected, but then we ended up with another header. And we're receiving the beginning of the file again. That's weird. The only thing I can think of is the way I was getting doubled up. So when I was doing the lister one, I was getting doubled up responses. And the way I was dealing with it was checking the currently incoming data against the previous data. And if it was the same, then basically ignoring it. And I have the same code here, but if our duplicates came out of order, it would break that logic. Because it might not be the same as previous one. But this is all part of one packet or whatever. This is all one response. So why would we ever receive a single response that contains that much of the file and then starts over with a new header and the beginning of the file? I don't see any way. I don't even see any way how we would receive that. Like, how would we even ask for that in order to get that response? So are these chunks maybe supposed to be... Could it be the index? That's so weird because we started, like, we received the next bit of data. Like, we must have asked for the correct offset. How much? How much is up to here? Is that 192 characters? Huh. I mean, the only thing I can even... The only even remote idea that I've got is that it's the duplicated receives, and the only thing I can think to do to try to solve it is try to make this logic better. Received packets. If data not in received packets. Received packets append data. So if we receive a packet and it's the exact same as one we got before, ignore it. Don't add it to incoming data buffer. Because the only thing I could think is, like, we're receiving a duplicate, like, while just in the middle somewhere. Like, I don't know. Honestly, it doesn't make that much sense, but I have zero other ideas so far, so... $496. Up to $992. Oh, it's the same thing. We just randomly get the file. Beginning again, the header. Is it the exact same header? Actually, we had 2 extra bytes after the while BLE connected. Got a new line in a space. Does that get us to the 1024? Maybe our original chunk size? Because that's 992. New line space. Is that 1024 from there up? It is. I probably don't know how the chunk works. Maybe always using the chunk size, so I told it to just always use the chunk size 1024. Let me reread all of this again. Okay, read a file. Given a full path, returns the full contents of the file. The header is 4 fixed entries and a variable length path. The first byte is the command. It's a single byte. It's always 0x10. 1 byte is reserved for padding. The path length, 16-bit number encoding the encoded length of the path string. How big the path string is. The chunk offset, 32-bit number encoding the offset into the file to start the first chunk. Offset into the file to start the first chunk. Chunk size, encoding the amount of data that the client can handle in the first reply. Honestly, why is this a 32-bit number? That's kind of big, right? Isn't the maximum then like very, very large? Why is this a 32-bit number if I am asking for 1024 but only getting back like 512 at a time? Anyway, that's another question. Let's not get sidetracked. Okay. The amount of data the client can handle in the first reply, the path. UTF-8 encoded string that is not null terminated. Okay. The response, command, single byte, always 11. So first byte is the answer that says 11. The next is a single byte for the status. Actually didn't get to comparing this before I got on the tangent. And now I'm interested if we do compare this. Okay, so that is a single byte for the status, which I believe is successful. Status byte 01 for okay, yes. So these headers are in fact both the exact same, and they do in fact both have status okay. It says 2 bytes reserved for padding. Kind of weird that they seem to be sort of arbitrary values, though. I guess that's how it goes for padding, but next up we have 1, 2, 3, 4. Bytes, which is 32 bits, which is the offset into the file of this chunk. So in our case, both of these are encoding that. I don't know what number it is. We'd have to convert it. Chunk offset. And that is what we receive first time, too. Shouldn't that be 0? On the very first response we get, shouldn't that be 0? Maybe it is 0. Does that F? The F is part of the next one, isn't it? I think the F is part of the next one. We could print more of these out. I mean, yeah, at this point, I'm just in, like, literally question every assumption mode. So my assumption is that on our first response, the current offset will be 0. Okay, yeah. Command, status, content offset. Content length, which is 1638 plus 16 should get us to 1654, which is what we are expecting. That's when we're trying to stop. Let's just validate that. Again, I'm in question everything at this point. 16. Yeah, okay. And then we received 1024. So the number encoding the length of the red data up to the chunk size provided in the header. The number encoding the length of the red data, the length of the red data up to? What does that mean? The length of the red data up to the chunk size provided in the header. I don't know what that means. The amount of data the client can handle in the first reply. So this makes sense to me. This is the client saying, I can handle, in my case, 1024 bytes of data. And the server responded and said, 1024 is the length of the red data up to 1024? Because that's what we provided back there. 1024 is the length of the red data up to the chunk size. 1024 is the length of the red data up to 1024. I don't know what that means. Chunk length. I mean, I don't know what that means. Stare at this code for a minute, I guess. So they have a chunk size of 490. Okay. So inside read. Takes the path It makes a lowercase chunk size equal to shouty chunk size, which we know is 490. And maybe I should just use 490. I don't know. It seems like it's only. It seems like it's not. Well, I don't know what. I guess I don't know what I'm telling it with 1020. Like I thought that was how much data I can handle, which is what it says. But then I don't understand what the one it returns me means. See if we can try to discern it from here. So that's this is we haven't received yet. This is just chunk size. We're starting on 490 start. So offset the very first time that should be on 0. It is for us as well. It is for us as well, right? We're starting on 0, aren't we? I mean, we're receiving the beginning of the file. We must be starting on 0. We're gonna question everything though. Let's question everything. Here's the first one we sent. That one's down here, I guess. Oh, 0, right there. And then chunk size. Offset. Okay, we're definitely asking for 0. We're getting 0 back as well. Okay, so we're encoding, we're making a command. Our command is the pack of the read command, that's 0x10, filler byte, the length of path as 16 bits, the length of the path of the file we're asking for, and then offset, which will be 0 the first time, and then chunk size, which will be 490 the first time through here. Then it's adding the path, which has been UTF-8 encoded. Then it is writing it. So for our code, all of that occurs down here. Really more like right here. Then the next thing it does is create a byte array that is the header plus the chunk size. So it's preparing to receive the header and then how much data it asked for. Then it's setting current offset to start offset, which at this point is still 0. Setting chunk done to true, content length to none, chunk end to 0, buffer is a new empty list, data header size is, we know, 16. While content length is none, or current offset is less than content length. So current offset we know from here is 0 currently. So we're basically saying we're going to loop while content length is none or the current offset is less than the total size of the file. So read into B. So that's going to fill this byte array that was created here with data that's coming in. It's going to save a number for how much data it read. It's going to say if chunk done chunk done is just hard-coded to true, though. Just kind of weird. So we're in here, we're looping, we read, we say if chunk done, which is true, we know it's true because it's hard-coded to true. Then we are going to unpack the data that came in that we read. So command status content offset content offset, which is called content offset here, but is the chunk offset here. Okay. Content offset, content length, and then chunk length. Content offset, content length, and then chunk length. Okay. Unpacked, and then it says chunk end, which was 0 before, but that's being equal to content offset, which was chunk offset, plus chunk length. Chunk end equals chunk offset. So we received back zero for content offset. And our chunk length was 1024. So if this code were our code, chunk end would have been 0 plus 1024. This code is then saying, if the command is not read data, then we have an error. If the status is not okay, then we have an error. If buff is falsy, i.e. empty, which we know will be true the first time through here, then buff becomes byte array that is content length minus start offset, which we know is 0 still. That's very confusing to me. Minus start offset. Where does start offset originate? Because, oh, this is that stupid highlight. Actually, this got me yesterday too. I don't like that. When this is clicked, I want this to highlight. So it comes in as 0. Like, we're always going to be passing 0 to read, right? I'm never really trying to read the second half of a file. The command, the like read pacing, that is, but the user, the API, is never trying to read anything other than offset 0. So start offset, we know is 0 still here. So we're allocating a byte array that is the full length of the content. Out offset equals current offset minus start offset. So current offset got set to start offset, and it's 0 for us. So 0 minus 0 is 0. So out offset is 0. So then we're going to go and say buffer 0 to 0 plus the amount of data we read minus the header size. So 0 to the length of the data we received other than the header. We're going to set it equal to data from B, which is what we read into here, starting at data header size, so after the header, going to read. So starting after the header, going to the end of what we read. We're going to put that into buff. Current offset plus equals read. Read, how much data we read, minus the header size. How much data we read minus the header size. So this was all if chunk done is true, which the first time through here it was because it's hard-coded. So all of this has now happened. Else, we don't go to else because chunk done was true. Now we say chunk done equals current offset, which we just updated here to be the amount of data we read minus the header size. So chunk done equals current offset equals chunk end. Is the current offset... Oh, it's doing that again. I really don't like that. I almost want to just get out of here. Get into PyCharm. It just makes it so much harder when it's trying to follow what's happening when it's not highlighting all the instances of a thing. Especially because I don't fully understand the rules around how it's choosing to highlight or not. Of course, yeah, no, this is not actually any better because... Oh, okay, I don't know, maybe this was still running or something, I guess. It wasn't working, but now it is. Okay, and I've lost my train of thought. So, chunk done equals, it's doing it again. Not working. That's really aggravating. I don't know, that one just doesn't work. Only the other ones work. Okay. And it's the same problem, actually. If I click this one, it knows to highlight this one. But if I click this one, it doesn't know to highlight this one. It's like not reciprocal. What is that? Okay, whatever. Chunk offset. So if it is equal to the end, so end got set back up here. The content offset, which was 0, plus the chunk length, which was, in my case, 1024. So chunk end would have been 0 plus 1024, so 1024. So chunk done is current offset equal to chunk end. If not chunk done, continue. So skip the rest of the while loop, go back to here and do all this again. I don't understand that. Chunk done, if the current offset is equal to the end, if we're not done, then continue. So come back up here and read again. But that doesn't make sense. We haven't sent the command to ask for more. Is that not what continue does? What does continue do? While, so like I equals 0, while I is less than 40, print before, let's say 10, here 5, while I is less than 5, print before, print after, if I equals 3, continue. So what I think this does and then let's do it here, I guess. So what I think this does, we start on 0, we go up to 1, we print before, we are not equal to 3, we're equal to 1, so we print after. Maybe let's also say print I. Okay, so we're up to 1, we go up to 2, we print before, we print 2, this is not, we print after, we go up to 3, we print before, we print 3. That's true, we continue, therefore we do not print after. We wrap back around, we go up to 4, we print before, we print 4. That's not true, we don't continue, we print after. So on the, when I is 3, we skip after. That's what I think continue does. Yeah. Got no after on 3. Okay, that's what continue does. So how does this make any sense? Because if not chunk done, if chunk done is false, continue, we go back to here. We read into B again. But how are we going to have new data? We can't. Well, so is that because we received the header by itself first? All right, BRB also. Okay. So the very first thing that my code reads is a header only. And the very next thing it receives is 496 bytes of the file, starting at the beginning of the file. So B gets allocated to header size and chunk size, which was 490. So their B is getting allocated to 490 plus 16, 506. So does read into, will it only read the header somehow? Will it only read 16 bytes? Or will it read all the way up to, will it read 506 bytes? Okay, I don't know. Anyway, I think let's pretend this isn't here, I guess. I don't, like, that's never gonna work, but I don't understand how this can work. Like, in my mind, we would get all the way to here. Chunk done is gonna be false because current offset is the amount of data we read minus the header size, so 506 minus 16, 496. Current offset is 496. Chunk end is 0 plus chunk length, which I got back 1024, but that's because I asked for 1024. I mean, I guess. I don't actually know why it's Y, because I don't understand what it is. Chunk length. So chunk end, so I mean, if we assume that this code would get back the same, then chunk length would be chunk size, which was 490. 490. Why 490 too? That's such a weird number. So chunk end would be 0 plus 490. And current offset would be 506 minus the header, which is also 490. Okay, so chunk done would be true. Okay. So is it ever false, I wonder? Does this ever actually, I don't know. Okay. So sure, chunk done is true. We don't continue, we don't read again, we keep going. Chunk size is the minimum of, or the lesser of, chunk size, 490, content length, 16,840 something, 1648 or whatever, minus current offset, which is how much we read, 506 minus the size. So 490. Current offset is 490. So the minimum of 490 and the total size of the file, which is 16 whatever. 1638. Minus current offset, 490. So that means that just 490 by itself should be less, I think. 1638 minus 490, 1148. So the minimum is the chunk size. Okay. So 490. So then we say if chunk size is 0, then break, which would break out of the while loop, which would actually cause us to return the buff. But if we don't break, then we say here, we're going to encode the next command. So read pacing, okay, current offset, which is 490, and chunk size, which is also 490. It will write it. And then it will loop in this while loop. So one thing that's definitely happening, though, is that it is changing the chunk size, which I'm not. So I don't understand what this number actually represents. The length of data read up to the chunk size provided in the header. The length of data read up to the chunk size provided in the header. I don't know what that means. But it came out as the same size that I asked for. The only one that I can see so far. And then chunk size here in the 12, in the command we asked for the next piece, read pacing, the number of bytes to read. May be different than the original size, and I take that to mean the original chunk size, i.e., how much data the client told the server it could handle in the first reply. So this is saying when you ask for more data, you're allowed to ask for a different size than you asked for before. And then it says, does not need to be limited by the total size. But this code here looks like it is doing that. Because this code is gonna make the chunk size eventually equal to however much of the file is left that's less than the actual chunk size it's using, 490. So eventually, 1638 minus the current offset is eventually going to be less than 490. And then this is going to use a chunk size that is less than 490. Maybe this is not true. Maybe it needs to be limited. And then And something is definitely wrong with the chunk size, because that's the place where it breaks, right? It's not, it can, I mean, it could be, I guess, but I think it's very unlikely to be a coincidence that the exact number of bytes that we received before it broke, what I'm saying broke, which was it received the beginning of the file again, that was exactly 1024 bytes. And so we got, how many successful ones did we get? So we received the header, no problems there. We received the first 496 bytes, no problems there. That got us all the way to after import provide services advertisement. That got us all the way to the fro right there, and then up. That was the technically the second response, but the first one that contained actual data, not the header. So we got that. So it gave us an offset of 0, which makes sense. We got the very first byte of the file. We started at 0. It gave us the total size, and it gave us chunk size, which again for us was the exact, I mean, it's returning to us again the same thing we asked for. So we asked for data at offset 0. We got data at offset 0. It says the chunk size is 1024. And then we went all the way from that M at the end of from right there up to last send equals time.mono. Monoto. So we stopped right there with our technically third response, but second of our responses that contain file data. Like, not the header. So our first and second responses that contained file data were correct. They contained the correct file data. However, this still says offset 0. But that's no longer true, though. That shouldn't be 0. So are we sure we're printing the new version of that? It's always printing the same. Because we asked for an offset of 496. So, hold on though. We receive data without headers, but how does that work? How we should get a header with the next piece of data, shouldn't we? So the chunks, I do not understand the chunk size at all. I don't know what chunk is supposed to be. Because we're asking for 1024 and not getting it, so I don't know why it allows 32 bits. I don't even know really what it's supposed to do. I mean, it sounds like it's supposed to limit how much data gets sent back to you, but it also seems like it just ignores whatever you ask for anyway. So I don't get why it wasn't just hard-coded to whatever number it was going to decide on anyway. There's probably more to it than I understand. Certainly there's more to it than I understand. But then, so you ask for a certain amount of data, and then I don't know what this one is telling you. Like, I'm not sure what that number is supposed to represent. The encoded length of the read data up to the chunk size provided, up to how much you said you could handle. But like, what is a single number that means the amount of data we read up to the amount of data we said we could handle? Like, I can't really reconcile the one number up to another number is what this single number is. Like, I don't know what that means. And then chunk length. Okay. Oh, right. So this is duplicated. So this should be chunk data. That doesn't help, but doesn't necessarily hurt too bad now that I'm seeing it and I can see it's doubled. So this is just not chunk length. So if the chunk length is smaller than the total length, so in our case, so we asked for 1024 and it sent back 1024 as the chunk length. But it only sent 496 bytes. And then when it sent that 496 bytes, it sent it Well, it sent it without a header. Well, I mean, the first header was the header for the first chunk. But the actual receive came in with just the file content and no header. But when we print this unpacked values, that is coming from our incoming data buffer. So in my code, that's always the entire data, which will always start with the original header. So I am just printing the same thing over and over. But this one, so this is the header that goes with this chunk of the file. And then we send a read pacing, a 12. We send a 12, and we say the offset to start the next chunk should be 496. But then we receive data with no header. Let's not send the read pacing command. I want to see if we receive, I want to see how many things we receive and how much data we receive if we don't send the read pacing command. Maybe we're supposed to be waiting. Maybe we're supposed to be waiting until we have received 1024, and then only after that we're supposed to send the read pacing command. But it might take multiple receives to get up to that 1024. This is all a hypothesis. So let's not send this. Let's just say print not sending read pacing. But let's do calculate the offset, and let's do print what the offset would have been. So in the way this code is written, it's expecting that it should only get one response. But we're getting multiple. Okay, so that's why the code doesn't work. Yeah. Okay, so I was incorrectly assuming that the data that this thing right here is describing was a chunk. I thought this was a chunk of data. And now, based on the results of this experiment, I no longer think that's true. I think a chunk of data is defined by the asker, the client. The client says right here, this is the chunk size, therefore a chunk is that many bytes. Or maybe less if the file is smaller, I'm guessing. And so you can send one command to read a file. You set your chunk size, and then you can receive multiple 11s, multiple read responses. You're going to get some number of bytes each time. It seems like 496, but let's just say it's some number. I don't know how it decides. You then need to receive n times. You're going to receive over and over and over until you have received the amount of data you asked for, 1024. And then, once you have received the amount of data you asked for, then you need to send read pacing, the 12. How's it going, Johnny? Hope you're having a nice day, my friend. And if we, yeah. So this is 1040. So when we no longer sent the read pacing, we ended up reading the header and the amount of size we asked for. We ended up reading a chunk plus a header. Because 1024 plus 16 is 1040. Okay, I feel like I have just made a bit of a breakthrough. Rainy day, so relaxing inside. Nice. It's on the opposite end here. It's kind of hot, but it's hot enough that I don't want to be outside. Although there is like work I could do outside, so I'm hoping it will cool off sometime in the next week or so. Okay, so we keep receiving over and over, and then we only need to send read pacing when we have received the amount we asked for. So if we get to here, let's say we need another check in here. If the size of data buffer is equal to the size that we asked to receive, the chunk size plus the header size, then we know that we need to send read pacing. We need to ask for more data. Else, if that is not true, sunny, hot day in the US, Northwest Desert, low humidity is plus. So, okay. Have we received the full chunk we asked for, we requested? If we have, then we're going to ask for the next chunk, and we know that we don't have the full file, actually, because back here is where we would return the full file. And I just noticed it's returning buff, which is empty. We should not return buff. Instead, I'm actually just going to return data buffer, even though it has the header in it. Eventually, we'll cut the header out. Just going to return data buffer. Okay. So then once we have completed our chunk, we are going to be asking for more. The current offset is going to be, so it would be, okay, hold on. We have a problem here. So this is only going to work on the first chunk. Because on the second chunk, our data buffer would be equal to 2 chunks plus the data header size. And we might be receiving extra headers. Oh my, if we receive extra headers. Oh, yeah, I don't know if we're going to do that. We might, and if so, that's going to make stuff even more weird. Because we're going to have to like try to cut them out somehow. Hopefully it just is data. I don't know if that can work though. Anyway, let's... okay, my brain is a little bit fried here, I'm going to be honest. So the current offset, so we need to know... So the current offset is... I mean, the current offset is still... It's still the length of the data buffer minus the header size, right? So after the first chunk, that's going to be... That's, you know, we're going to be asking for 1024. We're going to be asking for the chunk size. And then after the next chunk, we'd be asking for 2048 because it would be, because our data buffer then would have 2048 plus the header size if we don't receive extra headers. So length of data buffer, how much data we have minus the size of the header. That's where we're at. That's where we're at in the file with what we've received. And then I'll just say chunk size. I am going to just keep hard coding that. I know the other code was going down on that, but the I don't know if we need to do that or not. We'll see. Put this back to yes. And yeah, I guess we can go back to making that a variable. Okay, so we should be able to receive multiple times without doing the read pacing command. And then we should only do the read pacing command when we have received a full chunk, i.e. a full however much we asked for, 1024 in my case. Just going to do this proactively because I assume it's going to need it. Would it be useful to also return bytes or chunks remaining in order to keep track of the transfer progress? Maybe. Like, useful to the end user, definitely. Useful to me programming it, possibly. But I also am, like, honestly, really, probably pretty much honestly exceeding the capacity for how much stuff about this I can keep in my brain currently. So I am hesitant to add literally anything else that is not strictly absolutely necessary. Although it could, you know, it could be the case that it would help us get there, in which case it would be unfortunate not to include it, but I am also... Why is this a tuple? Why is that a tuple? That's the end. That's right there is the end of our first chunk. And then that's the first time that we actually asked for more was right there as well. All of this were all we just received after the first time. I don't understand why that's a tuple. Oh. Okay. Most likely that would have caused it to not work. I don't know for sure, but like putting a tuple into that probably would have been. Okay, we received the header. First data response, second data response, third data response. Asking for more data, the offset at 1024, very good, yes. But the data we get back is wrong. This is wrong. We said we're asking for more data and our offset is 1024, please. And that's right before we sent this. So right after this got printed, we sent that 12 saying we would like to fetch another 1024 chunk and we would like to start at the offset 1024. But the very next thing we receive is the beginning of the file again. So does it loop around like that thing I was saying earlier where it was like definitely nice to have but not essentially, yeah, having some kind of like notice that it's still going would be good. I mean, we got back basically the beginning of the file again. Here's where the loop is in the actual data. I'm going to change chunk size to 490. Maybe there's a bug and other chunk sizes don't work. Because I don't get, like, okay, hold on. Let's print this stuff. So I think I'm sending current offset 1024. But let's validate. Let's make sure we're actually sending current. Not sending current. Where's current? Two different variables. That one's on 0 still. We're probably sending 0 again, not 1024. So we asked for 0 offset again, and we got 0 offset again. Of course we did. That's what we asked for. Fingers crossed. Cool. Okay, so that is 16 bytes off, which is pretty close. That makes me think we just received an extra header, probably, right? We probably received an extra header. All right, so here's where we got to last time. So we're asking for more data. 1024 is our offset. We're printing the values. It is 1024 now. If we would have done it before, that would have said 0. We received a header. The header we received is different from the one we got before. So a command status okay, and then we got a padding and a padding on the space. And we got a 32 bits for the offset. So I would assume that that is 1024. I don't know if I can actually... Yeah. Okay. So our new header has, so we need to get rid of the header. Do we need anything from it? So if we didn't ask for the same chunk size every time, then we might care about something in the second header, in the nth header, in the headers beyond the first. Since we're asking for the same chunk size, there's anything we care about, because we don't need anything from the header in order to calculate the offset. The offset we're calculating based on the full data we received and the known size of the file. So attempt parse file, we can't do it inside of here because we're getting the full data buffer, which includes the original header at the beginning, and then the new header would just be somewhere in the middle, 1024 bytes in our case. So we need to be in here, and I guess we... So we did receive the header by itself. What if we... Okay, so we know the first header is going to have an offset of 0, and we know every other header is going to have an offset bigger than 0. And if I'm correct in that we don't need anything from any of the headers except the first one, then what we can do is just always look at the offset and if it's not 0, don't add it. To the full buffer. So we'll try to unpack from the received data, and then we'll say if content offset equals 0. But we can't do that because we also need to make sure it's a header. So if data is exactly 16 bytes and, well, is header size, doesn't exist. Why does header size not exist? Data header size? I'm gonna this out, but then I don't know if it's gonna keep working inside of there. It might need to be in globals, I'm not sure. Just gonna put it, I guess. Okay. If the length of the data is the size of a header, and if the first byte is 0x11, which is read data, actually gonna do I'm gonna do another one of these. I don't know if this needs to be in here yet. So if the data that came in is the size of a header and the first byte is the read data byte, then we are going to go on and check the content offset. If content offset is equal to 0, then we do want to add it to the incoming buffer because that's the first header. So we want to put that in the incoming buffer. We need it. But if it's any other header, we're not gonna add it to the incoming data buffer. In fact, if it's any other header, if it's another header, I think we just return, right? We just return. That way, we're not going to add it. We're not going to call attempt to parse. We're just going to return if it's a different header. So we could rewrite this to say not equals 0, then return. And then if we got past this, that means that either it was not a header, which means we want to add it to our buffer, or it was a header, but it was the first header because its content offset was 0. So it was the first header, it was equal to 0, we did not return, therefore we did add it to the incoming data buffer. Any other headers will not get added. If it happens to be the size of a header, but it's actually content, then this will not match, or if it does, then that will not match, and if it does, then you're attempting to write a file with what looks like a command inside of it, which is going to probably break it, but those aren't ASCII anyway, so hopefully you're not trying to write them into a file. If we get past that, then we add it. And we attempt to parse it. Print. Ignoring header packet. Bounds, so we do this. I'll also do this because I'm assuming that we're in a broken state there. Success true. So, and then we actually technically have the header to let me split that off. Data buffer 16 colon? Pretty sure that's... Zero, 1, 2, 3. So should we say 15? Not sure if that's supposed to be 15 or 16. Um, 16 it looks like, because we got an extra 0. So close. All right, moment of truth. We are still writing the file, right? Right, go and look at it. Target file, write. File contents, which is what came from there. Decode, yeah. So, all right. It's good at first glance. So, CircuitPy, this is what we got out of Bleak. What we got from Bleak is left. The actual code on the device, CircuitPy right here, is on the right. Yes! Made it. Let's try another file. Let's go and try a smaller one again, because now I've done a lot of changes around chunks. Let's do boot out, which was smaller than a single chunk. I'm gonna delete it. Target file. Boot out.txt. Not found. I'm hoping that we will not be having the failure mode where I have to restart the VM, the like break to REPL or CircuitPy. I'm thinking that the cause of that was us messing up this conversation, basically, like us leaving off with a 12 when we shouldn't have, or not sending a 12 when we should have, or something like that. Yeah, I'm hoping now, if we have our logic correct, that we won't get to that failure mode anymore. This failure mode where I just got, where it's like can't find MAC address, that one I don't know what the cause of it, or really why the solution seems to be working, but that seems to be the solution. Back and forth in there. And this one does look correct. We'll just... So that was from Bleak, from the device itself. Good to go. All right. What do we have for other files? Do we have anything like interesting or big? 10.4K code TFT timer. Let's try that. Code, I'll just copy it. Oh, no, it crashed. Well, it. So I'm actually guessing that what we're running into here is basically the same thing we were running into back when it would have been an infinite loop. Because several iterations ago in the code, we should have been infinite looping, because we basically had a recursive function that said, if these two things are not equal, then call yourself again. It was not actually calling itself, it was writing the thing, which was causing the BLE workflow to send another thing, which was calling the callback, which is what was calling itself. So it wasn't directly, but it was basically that. It was basically a recursive function whose ending condition never got met. It should have stayed infinite, but it wasn't. It was stopping. I am guessing we're having the same thing here, which is there's like some arbitrary time of like the script is going to finish after that time. It doesn't know it's still going. Basically nothing blocks, right? We call write, we call start notify, we call write, after write gets printed, we probably get some callbacks. So a bunch of stuff happens, but there's no other code here. So I'm going to make finished equals false. Inside of here, I'm going to go globals finish. Let's see. Thanks to this, I'm discovering as well testing so far Vector IO has proved to be more memory efficient. Nice. Bob Hamill from somebody who was in the help with channel yesterday. Yesterday or the day before, I don't remember. A couple days ago, maybe. Finished. So we're gonna set finished equal to success. And I'm actually gonna do it after I write the file. And then I'm just gonna make a busy loop here. I gotta run to the restroom again. I was gonna try to hold it until I sign off, but I'm actually just gonna do it now. I'll be right back. busy loop while not finished pass. Maybe like a little bit of sleep so that we're not just straight revving the CPU, but so that will just loop over and over until finished becomes true, which gets set by true whenever success was true there. So that should let it run until it's done, I think. It's not found, so we do this. Oh. Yeah, okay, so we're back to that other broken mode, but it kind of does make a little bit more sense. I know a minute ago I said I was hoping we weren't going to get back to it. I am still hoping we're not going to get back to it. In this case, it does kind of make sense, though, because without our busy loop that I just added, you know, like, we effectively just bailed in the middle of a transaction, right? Like, we asked it for a file, and then we just kind of stopped listening because our program died. Uh-oh. Okay, that's weird. So it seemed like it was going to be stuck, and then I pressed stop, and then after I pressed stop, it kind of got unstuck. Was I just jumped the gun? Should I not have maybe pressed stop so quick? Was it going to work? I mean, it felt stuck. I'm not going to touch anything. All right, we got a problem now. Oh, I think I need to do not time.sleep, but yeah, okay, so as soon as I press this is when it goes. I think I need to do not time.sleep, but rather like await async io.sleep, right? Because I need to let the rest of those awaits happen. Because we just got into that busy loop and then basically never let anything else go. We are still we are still stuck though. It's not working. So I think my logic on, because we're not asking for the next thing again. So we received the first header. We got the first bit of data. We got the next bit of data. We got the last bit of data within the first chunk. So then we asked for more data starting at offset 1024. We got back the header from when we asked for more data. We ignored the header packet, so we did not add that to our incoming data buffer. We received some more data. We received some more data again. Then we should receive a little bit more data. Yep, a little bit more. So that would have been up to the 2048th byte, the 1024 times 2. That would have gotten us up to there. But we did not, there's no more asking for more data. This says asking for more data. We did that after the first chunk, but we should be doing it here, and we're not. So that's the next thing to work on, is files that are bigger than 2 chunks don't work. Files that are less than a chunk work, and files that are between 1 and 2 chunks work. But files bigger than 2 chunks do not currently work. But we're much closer than we were. It's been a wild ride today. Yeah. I thought of this problem earlier, and I guess for some reason I thought I had solved it, but the truth is I didn't. So what we're saying here is if the amount of data we have received is equal to the chunk size plus the data header. So have we received one single full chunk? Somehow we need, it should not be always checking for one chunk specifically. It should be checking for, like, we need to know if we're at the current chunk we're supposed to be on. I don't know a better way to describe it. To do, this logic is broken for files that are larger than 2 chunks. It's always comparing data buffer size to the size of a single chunk specifically, but needs to compare to n chunks based on, you know, how many chunks we've received in this section. I don't know if that's the best way to actually write that, but I think I will understand it when I get back to it, which is the most important part. I'm going to wrap it up there. Thank you, everyone who is watching. Thanks to C. Grover and Johnny Bergdahl over in the chat. It was nice to see you, my friends. I hope everyone has a good rest of your Saturday, a good rest of your week. I'll be back on next Saturday at the same time, 10 a.m. Central Time, working on some more CircuitPython stuff. Yeah, like I mentioned last night, I haven't talked to Scott, so as far as I know, Scott's back for a deep dive this week, but that's subject to change as well, because like I said, I haven't talked to him, so I'm not sure. But I will, I should be back on Saturday for sure next week at the normal time. So take it easy, so long, farewell, and until next time, I will see you later.